So let's talk about types of compounds. We need to understand the three types of compounds that we'll be using in this class before we can actually take compounds and try to figure out what type they are. So we have ionic compounds. Those are compounds that are composed of a cation and an anion. A cation might be a metal cation or it might be a polyatomic cation, and it's bound to a anion, either a non-metal anion or a polyatomic anion. Covalent compounds are compounds of two nonmetals, atoms of two or more nonmetal elements bonded together. The third type of compound we have is acids. And acids are composed of hydrogen covalently bound to other nonmetals, but sometimes acids break up to produce a hydrogen cation. We'll discuss more about that in Chemistry 102, but for now we just need to be able to recognize acids. So when we try to look at a chemical formula and determine what type of compound it is, if it's an ionic compound, I'm looking for things that start with a metal chemical symbol. It might be, remember, metal elements are those elements that are left of the staircase on the periodic table. Also, it could start with a polyatomic cation. There's really only one notable polyatomic cation, and that's ammonium ion, which has a formula of NH4. So if we're seeing a formula that's beginning with NH4, we're thinking that this is an ionic compound. Also, it will end with a non-metal compound formula, chemical symbol, or end with a polyatomic anion chemical formula. So I will be looking for those. It may contain parentheses, and that's like the key components for looking at ionic compounds. On the other hand, covalent compounds are going to start with a non-metal chemical symbol. They're going to end with a non-metal chemical symbol. Again, metals are those elements to the left of the staircase on the periodic table. Non-metals are those elements to the right of the staircase on the periodic table. Acids are notably going to begin with H, begin with the symbol, the chemical symbol of hydrogen. So that's mostly what we're looking for. They could end with either a non-metal chemical symbol element, or they could end with a polyatomic anion. So they can be a little tricky. So for acids, we're really looking for that hydrogen at the beginning. So if I have a chemical name, we're looking for something a little bit different. Same strategy, but slightly different things. We're going to be starting with, for ionic compounds, they contain metals or polyatomic cations. So we're looking for the words beginning with a metal element name, or ammonium, because ammonium is really the only polyatomic cation that exists that we're going to be talking about. They may have Roman numerals in the chemical name. They can end in "ide," "ate," or "ite." On the other hand, covalent compounds are going to contain a non-metal element chemical symbol or chemical name in the first word. So, and then they may have prefixes of mono, di, tri, tetra, all the way through our Greek letter prefixes in them. And they may be prefixes in both of the words in the name. They're going to contain a non-metal element name in the last word of the chemical name. And they're always going to end in IDE. Acids are going to end in either ic acid or us acid. The word acid is directly in their name, fairly easy to type an acid by its chemical name. They may or may not begin with hydro. You'll learn more about that of naming acids. So some examples we might have, Na3PO4. When I'm looking at this is a chemical formula. So I'm looking for, it has sodium, which is a metal chemical symbol. PO4 is phosphate. That's on my polyatomic ion chart, so I know that's a polyatomic anion. So this is definitely an ionic formula. When I see sulfuric acid, the word acid is a dead giveaway. This is an acid. N2O3. I see N is a nonmetal element, O is a nonmetal element with two nonmetals. This is going to be a covalent. Copper 2 chlorate. Whoops. Copper 2 chlorate has copper. That's a metal element. It has Roman numerals in it. Anytime you see Roman numerals, it's a dead giveaway that it is a ionic formula. Also, the ending ATE, we're only going to see 8 and 8 endings with ionic formulas. So this is an ionic formula. We have CaCl2, and that's calcium is a metal element. It's one of the elements that appears on the left side of the periodic table. We have Cl, that's a nonmetal. So we're looking at anything with a metal symbol in it is going to be an ionic formula. HCl. So I see it beginning with a hydrogen, acid. Bromine, pentafluoride. Bromine is the name of a nonmetal element, and fluoride is the name of a fluorine is a nonmetal. The penta is also a dead giveaway. Anytime I see any of those mono, di, tri, tetra, penta, hexa, I know it's covalent. The only one that can be slightly tricky is di. Di, sometimes there's some polyatomic names that have the prefix di in them, but all the others indicate for sure it's a covalent formula. NH4Br. So nitrogen is a nonmetal, hydrogen's a nonmetal, bromine's a nonmetal. You might be tempted to think that this is a covalent compound because it has all nonmetals in it, but remember, NH4 is the chemical formula for ammonium polyatomic cation. So because it has a polyatomic cation formula in it, it's going to be an ionic. Anything that begins with NH4 is going to be ionic. The last one is aluminum nitride, and aluminum is a metal element. Metal element, this means it's going to be an ionic compound formula. So you can see how we can look at the formulas and the names and determine whether it's an ionic compound, a covalent compound, or an acid.